Have you ever wondered what those numbers after DDR mean when shopping for RAM? DDR3, DDR4, DDR5? Well, today we're taking a deep dive into the fascinating evolution of DDR memory, from its humble beginnings to the cutting-edge technology we use today. So stick around, because by the end of this video, you'll understand everything about DDR RAM and why each generation was a game changer. Let's get started. Before we jump into DDR, let's quickly talk about where it all began. Back in the 1990s, computers used something called SDRAM, or Synchronous Dynamic Random Access Memory. SDRAM was revolutionary because it synchronized with the system clock, making data transfers more predictable. But there was a problem. SDRAM could only transfer data once per clock cycle, which was becoming a bottleneck as processors got faster. Enter DDR. DDR stands for Double Data Rate. The brilliant innovation here was simple but powerful. Instead of transferring data once per clock cycle, DDR transfers data twice, once on the rising edge and once on the falling edge of each clock cycle. This effectively doubled the data transfer rate without increasing the clock speed. And that's where our story really begins. DDR1, also known as DDR SD-RAM, was introduced in the year 2000. This was the first generation that implemented the double data rate technology. DDR1 operated at voltages of 2.5 volts and came in speeds ranging from 200 MHz to 400 MHz. In terms of data transfer rates, you'd see modules labeled as PC 1600 up to PC 3200, where that number represented megabytes per second. Now, DDR1 used a 184-pin configuration for desktop modules. One key feature was the introduction of a notch in a specific position on the module to prevent installation in incompatible slots. While DDR1 was a massive leap forward from regular SD-RAM, offering double the bandwidth, it was just the beginning. The tech world wanted more speed, more efficiency, and less power consumption. DDR2 arrived in 2003, and it brought significant improvements. The operating voltage dropped to 1.8 volts, which meant better power efficiency and less heat generation. DDR2 speeds ranged from 400 MHz to 1066 MHz, with data transfer rates from PC2 3200 all the way up to PC2 8500. DDR2 increased the number of pins to 240 for desktop modules, with the notch positioned differently to prevent mixing with DDR1. But here's the clever part. DDR2 doubled the prefetch buffer from 2 bits to 4 bits. This meant the memory could grab more data at once and queue it up for transfer, improving overall efficiency. DDR2 became the standard for most computers in the mid-2000s, powering everything from basic office PCs to gaming rigs. In 2007, DDR3 entered the scene and dominated for nearly a decade. The voltage dropped again to just 1.5 volts, making systems even more power efficient. DDR3 speeds started at 800 MHz and went all the way up to 2133 MHz for standard modules, with enthusiast editions pushing even higher. The prefetch buffer doubled again to 8 bits, allowing for even better data throughput. DDR3 also maintained the 240-pin design, but with a different notch position. The real magic of DDR3 was its longevity. It offered the perfect balance of performance, price, and power consumption. This is why you'll still find DDR3 in many systems today, even though newer generations are available. It was reliable, affordable, and fast enough for most applications throughout the 2010s. DDR4 launched in 2014 and brought us into the modern era of computing. The voltage dropped to 1.2 volts, continuing the trend of improved power efficiency. DDR4 speeds started at 1600 MHz and now commonly reach 3200 MHz or higher, with enthusiast modules hitting 5000 MHz and beyond. The pin count increased to 288 and the prefetch buffer remained at 8 bits, but with improved architecture. DDR4 introduced bank groups, which allowed for more efficient memory access patterns. It also supported higher density modules, meaning you could get 16 or even 32 GB sticks in a single module. DDR4 became the standard for gaming, content creation, and professional workstations. Its performance improvements were substantial, especially in bandwidth-intensive tasks. And now we have DDR5, which started rolling out in 2021. This is the current king of RAM technology. DDR5 operates at 1.1 volts and starts at speeds of 4800 MHz, with modules already reaching 6400 MHz and beyond in the enthusiast market. The game changer with DDR5 is the doubled prefetch buffer to 16 bits and the introduction of dual 32-bit channels per module instead of a single 64-bit channel. This means better efficiency and performance, especially in multi-threaded applications. DDR5 also features on-die ECC, which is error correction built into the RAM itself for improved stability. The voltage regulation has even moved onto the RAM stick itself, allowing for better power management. DDR5 is designed for the future, supporting AI workloads, 8K gaming, and demanding professional applications. So there you have it. The complete journey from DDR1 to DDR5. Each generation brought lower power consumption, higher speeds, and improved efficiency. From the groundbreaking 200 MHz of DDR1 to the blazing fast 6400 MHz and beyond of DDR5, RAM technology has come incredibly far. If you found this video helpful, don't forget to like and subscribe for more tech content. And let me know in the comments what generation of DDR RAM are you currently using. Thanks for watching, and I'll see you in the next one.